I'm the strategic manager for environmental and food safety with Thermo Fisher Scientific, and I'm here at the ASMS conference in Salt Lake City, Utah, and I'd like to talk to you about an assay we've developed for the analysis of 510 pesticides using the LC-MS-Exactive platform. The reason for developing this poster was that we're finding that the number of contaminants which we are being asked to detect in both food safety systems, in food matrices, as well as environmental and drinking water supplies, the number of contaminants are going up, and therefore regulatory agencies are making the detection limits more and more stringent. Therefore, we needed to develop a fast and accurate LC-MS method for the detection of these compounds, both in terms of qualitative screening as well as being able to meet these strict detection limits. Now, typically in the past, analysts used either GC-MS or LC-MS and the triple quadrupole platform for doing targeted assays, knowing full well exactly the components they needed to identify and quantify. But because more and more unknown contaminants are creeping into our food chain, what we need now is an ability to be able to detect the targeted list as well as potential new contaminants which may be found. Therefore, the assay must be able to cover targeted as well as non-targeted screening. And the Exactive Orbitrap platform is an ideal instrument for this because it operates in high resolution mode and has extreme high mass accuracy. Typically, we can achieve mass accuracies to less than 2 ppm. And here what we have is an example of 60 of these pesticides, a snapshot of the 510. And I'll just take you through what we're displaying here. On the left here, we have the list of the compounds in alphabetical order from ametrine down to warfarin. The elemental formula is given here, as well as the polarity of the instrument, which is being used to detect or ionize these compounds either in positive or negative electrospray. The theoretical mass is given, followed by the experimental mass and the mass accuracy in parts per million. We have given the retention time for each of these compounds. In addition, the LOQ, the limit of quantitation for each of these, is given, which ranges around the 1 ppb, part per billion mark, as well as the quant statistics. Only the R-squared values are shown here. Now, I mentioned earlier that some compounds ionize better in positive, of course, and some compounds ionize better in negative. Therefore, it is essential for the instrument to be able to do fast polarity switching between positive and negative modes. So here, this graph shows an example of this. The Exactive is able to switch between positive and negative polarities very rapidly. And on the left, we have a compound being detected in positive, and on the right in the same scan we have another pesticide being detected in negative electrospray mode. So we'll now move over to some results, and the figure here shows again a snapshot of the analytes we looked at. Specifically in positive electrospray mode, the detection limits range from 1 to 250 ppb, and on the right hand side, if you look closely, you will find the linearities for each of these. Similarly, this figure here shows a selection of pesticides in negative electrospray mode. Again, detection, the limits of detection is at 1 ppb, and the dynamic range is between 1 to 250 ppb. And on the right hand side here, we have the linearities for each of these compounds as well. So in summary, we have developed a very fast and unique HPLC method using the Axela 1250 pump, which is our UHPLC product, coupled to the Exactive benchtop Orbitrap platform. The total analytical runtime was 12 minutes for the detection of 510 pesticides. We initially screened this qualitatively using the high resolution accurate mass power of the Exactive, followed by quantitation of each of these pesticides. If you'd like to find out more about this work, please visit us at www.thermoscientific.com/ASMS. Similarly, we also have an application note written for this, which gives the full experimental procedure in much more details than is given in the poster, and that can be downloaded from our website again at www.thermoscientific.com. Thank you.